Ever get that feeling like you're a little bit under the weather, maybe a bit of a cough, but you're still pushing through? Turns out you could actually have walking pneumonia. It sounds, well, harmless, doesn't it? Like it's something you can just kind of shake off.
Right.
But the story behind this illness, how we even figured out what it was,
Uh,
is full of twists and turns. It's a real medical mystery.
it really is. Yeah, the whole journey of discovery is fascinating.
So how did we go from a time when doctors were basically stumped by this milder pneumonia to actually understanding what causes it, the sneaky ways it works, and how our bodies fight back? That's what we're going to uncover today in this deep dive.
Sounds like a plan.
Okay, so picture this. We're in the pre-antibiotic era. Pneumonia is a serious threat, often fatal. Doctors start noticing this strange form of it, less severe but still contagious. They call it atypical pneumonia.
Yeah, it must have been incredibly frustrating for those early physicians. You know, knowing that something was causing this illness, but not having the tools to figure out what it was. Imagine trying to solve a puzzle with like half the pieces missing.
Right. And to make things even more puzzling, the standard pneumonia treatments, they didn't work. Doctors suspected a virus might be the culprit, but proving that was beyond the technology of the time.
It was a true enigma.
Fast forward to the 1940s. A researcher named Monroe D. Eaton was working with hamsters, and he stumbled upon this strange agent that caused pneumonia in these little guys. And get this Eaton's agent, as it came to be known, turned out to be the very thing behind many human cases of atypical pneumonia.
What's really remarkable is this: even with this discovery, the true nature of Eaton's agent remained a mystery for decades. Researchers knew it was there causing the illness, but they couldn't see it. They couldn't identify it. Talk about a cliffhanger.
Okay, so we've got our shadowy villain, but no way to unmask them. What happened next?
Well, the plot thickens in the 1960s. With advancements in scientific techniques, Eaton's agent was finally revealed.
Oh, this is it, the big reveal.
It was mycoplasma pneumonia,
Mycoplasma pneumonia.
the smallest free-living organism ever discovered.
Hold on, the smallest free-living organism, like smaller than bacteria.
You got it. It was unlike anything they'd ever seen before. And here's the kicker. Mycoplasma pneumonia lacks a cell wall.
No cell wall. Okay, how does that change things?
This was huge because it explained why penicillin, which was the go-to treatment for bacterial pneumonia at the time, was completely useless against it.
Okay, so this is starting to make sense now. Penicillin attacks bacterial cell walls,
Yeah,
but if mycoplasma doesn't have one,
exactly. It's like trying to pop a balloon with a hammer. It just won't work. This discovery revolutionized how we understand and treat walking pneumonia. Finally, doctors had a target, a way to develop more effective treatments.
so it's not just about identifying the culprit, it's about understanding its weaknesses, right?
Precisely. And as diagnostic tools became even more sophisticated, more pieces of the puzzle started falling into place. It turned out mycoplasma pneumonia wasn't the only player in the game. Chlamydia pneumonia and Legionella pneumophila were also causing walking pneumonia, and even some viruses were getting in on the act.
So walking pneumonia isn't a single illness caused by one thing, but a collection of similar symptoms with a bunch of different culprits. I guess that explains why it can be so tricky to diagnose.
Absolutely. The symptoms and the severity can vary widely depending on which organism is causing the infection. This adds another layer of complexity to the whole walking pneumonia mystery. But we're just getting started.
All right, I'm all ears. What else did they discover?
Well, researchers started zooming in on something incredible: our own body's defenses against these invaders. It turns out a type of white blood cell called neutrophils plays a crucial role in fighting off pneumonia.
Neutrophils, those are the ones that kind of act like our body's own little army, right?
That's a great way to put it. They're like soldiers on the front lines battling to keep us healthy. But here's where it gets really interesting.
Okay, I'm sensing another plot twist coming. Hit me with it.
The effectiveness of these neutrophil soldiers, it can actually change throughout our lives. You know, think of it like this. Infants and older adults have less effective neutrophils. It's kind of like their armies aren't as strong or well-trained.
So even our own defenses aren't always a guaranteed win. That makes this whole thing even more complicated. But what about the weapons these neutrophils use? How do they actually fight off these invaders?
They've got some incredible tools in their arsenal. For one, they can release these sticky traps called nets, which stands for neutrophil extracellular traps.
Nets. Okay, that sounds kind of cool.
They literally capture and kill bacteria. It's kind of like a spider web. Then they can engulf and destroy invaders through a process called phagocytosis. Imagine Pac-Man gobbling up ghosts. It's kind of like that.
Wow, our bodies are way more action-packed than I ever realized.
And there's more. Neutrophils also produce these powerful chemicals called reactive oxygen species, or ROS. They damage pathogens from the inside out.
So it's like a Three-pronged attack. Traps, engulfing, and chemical warfare. But I'm guessing mycoplasma doesn't just sit back and take all that, right?
You're catching on. Mycoplasma has evolved some pretty clever ways to evade these defenses. Remember, this is a microscopic battle for survival. It can produce an enzyme that actually breaks down those sticky nets. It also makes antioxidants that neutralize the ROS.
So it's like mycoplasma has its own countermeasures for every weapon the neutrophils use.
Exactly. It's a constant back and forth, an evolutionary arms race. But here's the most surprising trick of all. Mycoplasma can actually hide inside our own cells. This makes it much harder for the immune system to detect and destroy.
Wait, so it's like a Trojan horse situation. Mycoplasma sneaks inside our own cells to avoid being attacked.
You got it. It's a master of disguise. But sometimes this microscopic battle can have unintended consequences. Our immune system, while incredibly powerful, can sometimes make mistakes.
Okay, what kind of mistakes are we talking about here?
Well, in some cases, the immune system can go a bit rogue and actually attack our own bodies. It's called an autoimmune reaction.
So our own defenses turn against us. But why would that happen?
Sometimes mycoplasma's antigens, which are like little flags on its surface, can resemble parts of our own cells. So our immune system gets confused and starts attacking healthy tissue thinking it's the enemy.
So it's like a case of mistaken identity. Our immune system sees mycoplasma, thinks it's something else, and launches an attack on our own bodies.
Precisely. This can lead to some of the more serious complications of walking pneumonia, things like heart problems, skin rashes, and even neurological issues.
This is blowing my mind. I had no idea walking pneumonia could cause all these problems.
It really highlights how complex and interconnected our bodies are. But let's go back to something you mentioned earlier, the challenges of diagnosing this tricky illness.
Right, with all these different causes and symptoms. How do doctors even know if someone has walking pneumonia?
Well, it used to be much more difficult. The symptoms are often mild, and they can overlap with other illnesses like the common cold or the flu. Early methods like culturing the organism or using serological tests, which look for antibodies in the blood, were slow and often unreliable.
So back then it was a real guessing game.
Pretty much. But thankfully, things have changed dramatically.
Oh, I bet. What's the game changer?
The development of PCR testing, specifically a type called real-time PCR, has revolutionized how we diagnose walking pneumonia. It's fast, incredibly accurate, and can identify the specific culprit causing the infection.
So we've gone from blurry images to like a high-definition picture. That's amazing.
Absolutely. And having this precise diagnosis is crucial for determining the best course of treatment and avoiding those potential complications we talked about.
Speaking of complications, there was a case report you mentioned about a woman who developed recurring skin abscesses.
Yes, this case is a stark reminder that everyone's immune system is different, and those differences can dramatically influence the course of an infection.
So what happened with this woman? Why was her case so unusual?
Well, she had a history of autoimmune disorders, which already suggested there might be some underlying vulnerability in her immune system. But the surprising twist was that mycoplasma pneumonia, the same culprit behind walking pneumonia, was the cause of these recurring abscesses. She was ultimately diagnosed with a condition called common variable immunodeficiency, or CVID.
CVID? That sounds serious.
It is CVI basically weakens the immune system, making people more susceptible to infections. Sometimes unusual ones like this. It underscores the importance of a healthy, functioning immune system in fighting off even seemingly mild infections like walking pneumonia.
So her case highlights how even an illness that many people just brush off can have serious consequences for some.
Exactly. And it emphasizes the importance of personalized medicine, understanding the individual patient's immune response to tailor the best treatment plan.
Wow, this deep dive has been an incredible journey so far, from a mysterious agent to uncovering the complex world of mycoplasma pneumonia and the immune system's fight against it.
It's a testament to the power of scientific inquiry and the relentless drive to understand and overcome disease. But our journey isn't over yet.
There's more. I'm ready. What else is there to uncover?
There is, and it's particularly relevant today with the rise of antibiotic resistance.
Oh, that's right. Antibiotic resistance is a growing concern worldwide, and I guess mycoplasma pneumonia is no exception.
Exactly. It's become increasingly resistant to some of the common antibiotics used to treat it.
So what are researchers doing to combat this growing threat?
Well, they're exploring a number of promising avenues. One area of focus is the development of new antibiotics that can specifically target mycoplasma and other atypical bacteria. Remember how we talked about mycoplasma lacking a cell wall, which makes traditional antibiotics like penicillin ineffective?
Yeah, it's like trying to use a hammer to pop a balloon, the wrong tool for the job.
Exactly. So, scientists are working on antibiotics that can target other essential mechanisms in these bacteria, disrupting their ability to replicate or even survive. It's a more targeted approach.
Makes sense, targeting their specific weaknesses. Are there any other strategies in the works?
Another exciting area is immunotherapy. This involves harnessing the power of our own immune system to fight off infections. Think of it like giving our own defenses a boost.
So instead of relying solely on antibiotics, we're finding ways to help our bodies do the fighting.
Exactly. Researchers are exploring ways to enhance the function of those neutrophils, our frontline soldiers. They're also investigating therapies that can target specific molecules involved in the inflammatory response, preventing the immune system from overreacting and causing damage to our own bodies.
So it's like fine-tuning our immune response, finding that sweet spot where it can effectively clear the infection without going overboard. What about vaccines? Any hope for a vaccine that can prevent walking pneumonia altogether?
That would be the ultimate game changer, wouldn't it? Especially for those who are more vulnerable to severe complications. But developing a vaccine for mycoplasma is tricky. Remember, its ability to evade the immune system and change its surface antigens. It's like trying to hit a moving target.
Yeah, it sounds incredibly challenging.
It is. But researchers are making progress. They're exploring new vaccine strategies that can target those constantly shifting antigens and provide long-lasting immunity. It's like outsmarting the master of disguise.
Wow, it's amazing to think about all the research and innovation happening behind the scenes to combat this illness.
Absolutely. The quest for a walking pneumonia vaccine is a testament to human ingenuity and our unwavering determination to conquer disease.
So we've come a long way from those early days of mystery and frustration. We've uncovered the culprits, explored the complexities of our immune system, and glimpsed the future of treatments and prevention.
It's been a remarkable journey, from a seemingly harmless illness to a deeper understanding of the intricate dance between our bodies and these microscopic invaders.
I have to admit, I had no idea. There was so much to learn about walking pneumonia. It's a reminder that even the most common illnesses can have fascinating stories behind them.
Exactly. And it underscores the importance of staying curious and informed about our health.
Well, thanks to this deep dive, I'm definitely feeling more informed and maybe a little more appreciative of my own immune system. Thanks for joining us on this journey of discovery. We'll be back soon with another deep dive into a captivating topic. Until then, stay curious and stay healthy.